Assalamualaikum and a very good morning. First of all, I would like to thank all participants for joining this webinar with the title of Electric Vehicle Charging Infrastructure and Standards in Malaysia. This webinar is broadcasted live on IEEE PES Malaysia YouTube channel and Facebook platform. This webinar is organized by IEEE Power and Energy Society PES Malaysia. I am Dr. Nur Zulaili binti Muhammad from IEEE University Technology Mara UITM, and I will be the MC for this session. So, before we start our webinar session for today, let's watch our video presentation on some brief introduction to the IEEE PES Malaysia chapter and also the activities that we had organized before. Okay? Thank you so much for your interest and attention. So now, without wasting time, we shall start our webinar session for today. Our speaker for this morning is IR Lee Yuan Hao from EV Connection Senior Berhad, and he will be giving the talk on electric vehicle charging infrastructure and standards in Malaysia. Before I pass the session to our moderator, Dr. Kanendra, I would like to inform you that if you have any question regarding the discussed topic, you can type your question in the YouTube or Facebook chat box. Dr. Kanendra will pass the question to the speaker during the Q&A session. Dr. Kanendra, to you.
Right. Thank you, Dr. Zulaili. So first of all, a very good morning and warm welcome to all participants to this webinar event. My name is Kanendra, and I'll be the moderator for this IEEE PES webinar session. The title for this webinar is Electrical Vehicle Charging Infrastructure and Standards in Malaysia. I would like to take this opportunity to introduce our speaker for this session. IR Lee Yuan Hao received his bachelor degree in electrical engineering from Multimedia University MMU, Malaysia. IR Lee is a corporate member of the Institution of Engineers Malaysia, IEM, a professional engineer registered to the Board of Engineers Malaysia, BEM. IR Lee is the chairman of the EV Charging Industry Association in Malaysia. He's a SEDA Malaysia GCPV design qualified person and also the TVV certified EV charger installer. In addition, he is a member of the working group for the Malaysian standards in electrical vehicle charging system. He is currently the managing director of EV Connection, EVC, and EV charging infrastructure service provider in Malaysia and Singapore. With that, I would like to welcome IR Lee to deliver his presentation. IR Lee, the floor is yours.
Okay, thank you very much, Dr. Kanendra, and also thank you very much, IEEE for inviting me to actually give a presentation on this. As an engineer myself, actually, I would be delighted to share my experience and also my knowledge regarding the electric infrastructure in Malaysia or in the country. So without further delay, maybe I can go straight to the, can you see my screen? Okay, so is the presentation slides on the slides?
Yes, it is there.
Okay. Okay, so one of the things I think we are all very interested is the electric vehicle charging infrastructure in Malaysia and what are the things that are coming in. Just a brief introduction of the classification of vehicles. I think for the classification of vehicles, we actually divided into 4 categories. The first one is the ICE, or what we call the internal combustion engine. We also have the hybrid electric vehicle. The third category we have is the plug-in hybrid electric vehicle, and also the BEV, or what we call electric vehicle. In terms of the hybrid electric vehicle, or some call it a mini hybrid, it has a combination of an ICE and also electric motor in the vehicle. The battery capacity is actually quite low, maybe about 1 kilowatt hour only inside. So you have cars like Prius and Jazz, the first generation of hybrids, which are the family of this hybrid electric vehicle. It is charged mainly by the ICE and also by the regenerative braking. So you see, from when the technology evolves, then the plug-in hybrid actually comes in. The plug-in hybrid has the same composition of the ICE and also an electric motor, but the difference is the battery capacity is actually way much higher than the hybrid electric vehicle. I think currently plug-in hybrids electric vehicle in the market can go up to about 18 kilowatts hour to 20 kilowatts hour of battery capacity, which is 20 times even more than the hybrid electric vehicle. If you were to drive on the battery range alone, they can actually take you up to 30 to 80 kilometers just on the battery alone. Cars like the XC90, the BMW 330e, and the X5 are some of the plug-in hybrids which are available in Malaysia, which already been sold for quite some time. The next one, which we are more interested, is the battery electric vehicle, or short form we call it EV. It has only the electric motor in the car. The battery capacity now I think can actually goes up to maybe about 100 kilowatt hour. Now the latest cars that you see is offering in the market, they offer up to such a capacity range. It has to be charged by an external power source. The EV range now is way better than 3-4 years back, when it's only about 100 to 150 kilometers. EVs now can actually reach 4 to 600 kilometers. Cars like Tesla, Nissan Leaf, Zoe, Kona are some of the cars which are already available here in Malaysia, which already you can see some of it on the road. Another thing that people are very curious, what are the total numbers of public charger in Malaysia now? As per what I got from the authority, the latest numbers of public charger in terms of the AC charger, it's about 600 plus. For DC charger, which is available in the market now, it's about 56. So that is the chargers which users can actually locate and also can find in Malaysia in terms of the total numbers. Definitely, the numbers are not sufficient. There will be a lot more required if the government is to move from the transition from the electric vehicle, from the ICE to electric vehicle.
Sorry, Ayarli, I think the
Yeah.
slides are not moving.
Oh,
Yeah.
okay.
Yeah, it is. Yeah. Okay.
I see. Okay. Then I think let me just
Okay.
maybe I'll just briefly go through a bit.
All
Okay.
right.
So in terms of the numbers of public chargers in Malaysia, I think they are about 600 plus, like I mentioned earlier. In terms of the DC public chargers in Malaysia, it's about 56 numbers. I think that is based on the latest count from the authority. In terms of the current electric vehicle and plug-in hybrid sales up to this year, I think 2022, we have about 30,000 of these units. Most of it's mainly the plug-in hybrids, consists of the major brands of these premium brands. We have the electric vehicle, which has actually increased significantly from last year with the policy budget 2022 from the government to actually encourage the uptake of the EV. You can see the numbers has increased more than 1,000 units on the road now in Malaysia. In terms of charging a plug-in hybrid, normally if you talk about charging an electric vehicle, many people think that it's actually like charging a laptop or thing. But just imagine charging a plug-in hybrid car takes up about 16 amp single phase, is equivalent to running a 5 horsepower record. So in terms of the safety wise, in terms of the power requirement, is actually quite high. That is why as an engineer, we have to take note in terms of the capacity and also the safety requirement to actually design the circuit to power up an electric charging vehicle. What are the different types of modes of charging? We have the mode 1 and mode 2. Mode 1 and mode 2 are what we call the portable charger. The difference between the mode 1 and mode 1 doesn't have a control box, mainly used for scooters and electric bicycles. Mode 2 are the ones which comes with the RCD circuits and also the control box, which is able to charge an electric vehicle. For mode 1, it's not permitted to actually use it to charge an electric vehicle. It's only mainly used for two-wheelers or something which requires a smaller capacity. Then we have the mode 3 AC EVSE, or we call it AC charging station. Then we have the mode 4, which is the faster type direct current fast charging station, which it's more expensive, but you can actually replenish your battery at a very short time. What are the types of AC plugs which are available in the market? For Japanese cars, mainly they have the Type 1 socket at the vehicle. Therefore, we need to use the Type 1 to actually plug it in to charge the car. Most of the other cars are using Type 2, Continental cars, and most of the cars that are in Malaysia, I think 95% of it is using Type 2. Type 3 are not so commonly available in Malaysia, but it's more in Europe, where in countries such as Italy and France, they required the vehicles to be the shuttle type of charger. In terms of the DC plugs, it's similar like the the AC plugs. We also have different types of DC plugs. In North America, they use what we call the CCS1. CCS stands for Combined Charging System 1. In Japan, they have their own DC standards called the CHAdeMO. For the rest of the EU and the rest of the markets, we normally use the CCS2. In China, which is one of the biggest electric vehicle market in the world, they use their own standard called GBT, or in short called Gopiao. In terms of the AC and DC charging, you might be wondering what's the difference between an AC and DC charger. For an AC charger, normally we don't call it an AC charger, we call it an AC EVSE, electric vehicle supply equipment, because by right it's not a charger, because the output of the EVSE is actually an AC before it goes into the car. The car has a converter to actually convert from AC to DC before it goes to the battery. The power of the EVSE output to the charger depending a lot on what we call the onboard charger. The capacity of the onboard charger will determine how fast the car is replenished using the AC wallbox or the AC EVSE. On the DC side, we have the DC charger, which converts the AC to DC at the charger itself before it gives a DC supply straight to the car and to the battery. These are some of the samples of the AC and DC charger which are installed. On the left side is an AC charger of 7 kilowatt. On the right side, you can see that the DC charger has output or has plugs of multiple outputs. The number one is nozzle number one is an AC type 2, which they actually can use it for AC. It can actually charge up to a 43 kilowatt power. On the nozzle number 2, you have the CHAdeMO 50 kilowatt power, and the nozzle number 3 is actually a CCS2, which is also up to 50 kilowatt. To those have yet to see an electric vehicle car, on the left side is actually the Nissan Leaf here, the Nissan Leaf. So Nissan Leaf at the bottom there is actually the nozzle that is available at the car. On the left side here, you can see that the charger is actually a CHAdeMO, where you can actually insert the CHAdeMO plug into the car. On the right side, you can see that there's actually a Type 1 socket for you to plug into an AC charger. For a Mini Cooper fully electric car, they have what we call a DC and AC charging port. The AC charging port, the Type 2, is on the top there. The DC combines the other two pins at the bottom, so you actually have a DC charging port. But for plug-in hybrid cars, normally you don't see any DC. DC charger is not available. One of it is because the battery size is smaller. They might not need a DC charger. Therefore, they only have an AC Type 2 at the car itself for you to charge and using an AC charger. This is just an illustration in terms of the concept of AC charging versus DC charging. As mentioned earlier, you can see from the AC charging, it it has an onboard charger. It's like a converter to convert the AC to DC before it goes to the battery. Therefore, the power that can actually be charged to the battery depending very much on the onboard charger capacity. On the DC charging side, conversion is done at the charger itself before it goes straight to the battery using the DC power supply. Another interesting question that people will be asking, where do we install AC and where do we install DC charger? AC charger are normally installed in homes and offices where you have actually overnight or you stay long in places where you can actually have a very good charging time from 4 to 16 hours depending on your power capacity. Some of the charger it's 3 kilowatts, some of it is 22 kilowatts. So depending on the battery capacity and also the onboard charger and the charging capacity, your charging time can vary from 4 to 16 hours. For the commercial side, normally if you put it in a petrol station, normally we do not put an AC charger. You wouldn't want to wait few hours at a petrol station to wait for your car to charge if you want to balik kampung. So most of the petrol stations and the places where you need a quick charge, they will install a DC charger. DC charger can replenish your battery into to 80% about 15 to 60 minutes for a 50 kilowatt. For a higher rating or higher power capacity, such as 150 to 350 kilowatt, it can replenish your battery up to 80% from 5 to 20 minutes, depending on your car capacity as well. One of the most ambitious projects currently we are doing now is we are trying to electrify the highways and the destination charges along the major route. Two items which deters the adoption or accelerate the adoption of electric vehicle. One of it is the price of electric vehicle is still on the high side. The other one, it's the charging infrastructure is not sufficient. These are the two things that I think is slowing down the adoption of electric vehicle. So what are we trying to do as a company and also as an engineer? We want to make sure that if you were to travel from Kuala Lumpur back to your kampung in Penang or back to your hometown in Johor Bahru or Singapore, you can actually travel via the North-South Highway where you can actually use the DC fast charger along those routes to actually charge your car. So that is something that we are very passionate about, to make sure that the highway infrastructure is actually able to support the electric vehicle increase and adoption in the country. This is one of the sites that we have actually installed in Caltex IACRO at the northbound side. So you can see it's actually a 50 kilowatt DC charger. On top of the the roof of it, we actually put up solar panels to support the DC charger output. One of it is a lot of people say that electric vehicle is green because it's zero emission, but the source of power that you are getting it from is mainly from the TNB grid, which is mainly from fossil fuel. So we want to make sure that the generation side of the electricity supplied to the charger is also consists of green, so that we can actually cover the whole ecosystem or the whole cycle of the generation all the way to the charger side. Another thing that we are also currently doing, I think Shell Porsche is actually has actually invested a lot of money to actually electrify the highways at the Shell stations along the North-South Highway. You can see that there will be 6 more chargers coming up along the highway in places such as Simpang Pulai, Tapa, Seremban, and northbound, southbound, in Pago, and also in Tangkak. The first one has already completed in Shell Tangkak R&R southbound. It's a 180 kilowatt charger. Another 5 should be able to be completed by end of this year. Then we also have brands such as Petronas or Gentari, which are also pushing out the DC charger along the highway. They have also partnered with brands such as Mercedes-Benz and Jom Charge in terms of electrifying the highways. So these are some of the projects which are some of the companies which are trying to increase the charging points and the charging infrastructure in the country. Then we also have the recent TMB and Plus MOU signing to have another 8 DC fast charger along the highway. That is some of the things that are happening in terms of the increase of the infrastructure in the country. With that, we hope that the adoption or the acceleration of the electric vehicle will be faster. And as per what the government mentioned, they target to have at least 10,000 electric vehicle charging stations in Malaysia by 2025, based on the reply from our Deputy Minister of International Trade and Industrial, Senator Datuk Lim. That was in March. So I think currently we are about less than 1,000. I think we will need to have at least every day to have at least another 5 to 10 installations to meet the numbers of 10,000 electric vehicle chargers in Malaysia by 2025. So I think we have done quite a number of these DC fast charger installation along the highway. Some of the things that we face or the challenges that we face along the way. I think, as you know, that the COVID actually accelerate the adoption of ESG, environmental, social, and governance, and also the electrical vehicle adoption in the world globally. Every country in the world has set a standard when they want to phase out the ICE cars. Some are very aggressive, some they have set it later, and also you can see that OEMs has also set targets when they want to phase out ICE vehicle from their staples of products offering. With all these things moving at a very fast pace, there's actually a shortage of raw materials in terms of making of EV charger. So you can see that if you were to place orders for an electric vehicle charger in terms of a DC charger at a certain power output, the stock availability might not be there. They can actually range from 3 to 6 months or 8 months, depending on the brand that you want to buy. So there is actually a challenge in terms of getting this kind of supply in to actually put up at a very fast pace in the country. Then, of course, when you are putting up a charging station in those areas, I think we also will need to get the approvals from the authorities. Some of the authorities, if you are doing it in the highway, some of the authorities that you might encounter are such as Lebuh Raya, Lembaga Lebuh Raya Malaysia, LLM. You will need to get approval from them to get before you can actually do any work. Then we also need to get the approvals from Plus, the highway concessionaire. And besides that, if you were to erect structure in terms of the shape, you also have to get an approvals from the local authority. Depending on the area of your R&R, you will need to get the local authority at the certain location to actually erect that. Besides doing all that, there will also be an issue on the power availability. As you know that R&R are not designed for you to actually install charger, since it's been planned, I think, for the last 5-10 years. I think that is something that I think as a charge point operator or as a company which wants to install charger, we will need to apply for additional power supply to support those kind of high power charger which you can see earlier. One of those 180 kilowatt DC charger will take up about 300 amps in terms of the power requirement. For those who are not familiar with 300 amps, normally a household has about 63 amp 3-phase. We will need about 5 households to power up one of those 180 kilowatt charger. Therefore, you will need to have either the substation which has available capacity for you to actually route it to the charger. If not, there will be an additional requirement where you will need to build a compact sub next or nearby the charger to actually support the rollout of the 180 kilowatt charging. Then there's also the EV charging technical and competent person. I think since the electric vehicle charging field is actually quite new, there are not many competent or highly skilled people, especially on this EV charging field. So for us, like as a company, we will need to train up the engineers and the team to be competent in terms of handling the electric vehicle charging, making sure that the testing and commissioning is done properly, ensuring that we comply with international and local charging standards and also the product's requirement. That is some of the things that I think will need to build up the capacity in terms of the rollout of more EV chargers in the country. Next, it's the selling of electricity and versus selling of time. As you know, in Malaysia, if you were to sell electricity, you will need to get a distribution license from Suruhanjaya Tenaga or the Energy Commission. With the license, you can actually sell electricity like what is happening in malls. They get medium voltage supply from TNB or from Tenaga. They apply for a license to distribute a license to sell electricity to their tenants by selling it at low voltage price. And please take note that electricity is a regulated market. You cannot sell as what you wish to sell. It's similar like petrol prices. Therefore, that is one of the tricky part for us in terms of doing selling of electricity. Therefore, some of the chargers that we deploy, we sell time instead of electricity. For DC charger, we mainly sell per minute timing. For AC charger, we sell in terms of we charge in terms of hours. So depending on the usage, we will need to vary accordingly. But not to be worried, I think Energy Commission has also taken note on this. They are trying to come up with a licensing fee for charge point operators to be able to sell electricity in, I think, hopefully by end of this year. Next thing, it's also the standards, electric vehicle charging standards in Malaysia. I think when it was first started in 2013, I was part of the technical committee to actually draft out the standards for the IEC 61851 and also the IEC 62916 standards in the country. I think these are we actually kickstart the adoption of these standards to ensure that at least the installation and also the products which are coming in complies with all these local requirement and also the IEC standards. Moving forward, I think we are also in the midst to actually come up with standards on the DC charging side of it to ensure that the standards are adopted and also followed and comply by those that wants to partake or wants to sell the electric vehicle charger in the country. As mentioned earlier, I think ST has also now in the midst of coming up with the guide on electric vehicle guide on electric vehicle charging system. The draft has already been circulated among the stakeholders. I think we have also provided our comment in terms of what has to be done and what are the inputs as an industry will need to take note in terms of the charging side of it. I think the draft is ready, but I think they will need to finalize a bit more in terms of the details of it. From what I understand from Suruhanjaya Tenaga, I think they are planning to have it out by this year. Hopefully, we can come out early. So at least we have a guide in terms of the draft electric vehicle charging system, in terms of the product-wise, and also in terms of the installation and also the maintenance and testing and commissioning. Another thing that is very interesting, I think many people, when they install electric vehicle charger, they always think that it's actually quite simple. You just plug in the cables, terminate it to the charger, and let the charger. Once the charger turns on, then after that you plug it to the car, can charge, means it's okay. But as you know that the electric vehicle charger is actually meant for you to charge different types of cars. Not only on not only a continental car, or not only a Chinese car, or not Indian-made car. So you have to make sure that electric vehicle not only is able to charge one type of car, it should be able to charge all types of car. It's similar like the petrol station. If you were to pump around 95, you cannot say that these certain brands only can use it for certain types of car. We have to ensure that the charger is able to be able to charge different types of cars regardless of their makes. That is something that I'm always emphasizing when we were deploying chargers. One of the few things that we will need to take note is the simulators or these testing and commissioning equipments. we will need to ensure that the earth loop impedance, the RCD is tested before we can actually hand it over to the client or to actually open it up to the public. These are some of the equipments that we actually use it to actually monitor and to actually commission it before we actually roll it out to the market. So some of the loggers that we use, like fluke loggers, it's before we actually install a charger, we also need to do some loggings at the main incomer. One of the reason being is we want to make sure that if we are tapping it from an existing circuit, the power requirements drawn from the charger does not affect or does not trip the existing electrical supply at the building or at the store and etc. We have also different types of cars to do the commissioning. We also get cars such as Zoe, which is very sensitive. Therefore, there's always a saying say that if a Zoe can be charged, any cars can be charged because Zoe is a bit more sensitive in terms of their charging requirement. Then we also have the what we call a standing leakage current detector to ensure that the leakage current when they are charging the car does not exceed certain requirement, because we do not want to have some nuisance tripping when we are actually deploying those kind of charger. So without further delay, I think that ends my presentation. I think if you have any questions, I can take on a few more. Thank you very much.
Okay, thank you, Ali. I think that was a very interesting presentation. I think Ali has touched on various charging infrastructures, the standards, the facilities, the challenges, limitations, and such for EV implementation in Malaysia. I believe we have a lot of questions, but right before that, I would like to ask a couple of questions. So,
Okay.
Ali, Malaysia is currently on the path of becoming a carbon neutral nation by 2050,
Yeah.
as advocated by our national policies. Ali,
Correct.
how do you see does EV actually play a significant role in this?
I think EV helps in terms of the, I think in countries worldwide, in China or in India, people are moving towards EV. One of it is in terms of the dependent on fossil fuel. I think most of them do not want to be dependent on fossil fuel such as oil. Then we also have the issues of pollution, because you see with these ICE cars coming in, the places where the vehicles are actually all ICE, the pollution there is actually very bad. So governments worldwide are trying to address the issues of this low carbon and this thing. So electric vehicle does plays an important role in terms of it. If you were to compare what we are charging now from even from the fossil fuel grid, it is still more efficient to drive an electric vehicle compared to an ICE car. But if you have renewable energy at your generation source, I think this can even be lower than what is happening currently.
Oh, okay, all right, thank you. Another thing, Ali, that you touch is I think one of the concern with the EV users, which is range anxiety. So the range anxiety actually is a huge concern among these EV users. So, and the ICE cars have a faster refueling rate. Do you think in
Yeah.
future our EVs will be able to match or be on par, perhaps in terms of refueling or to alleviate the range anxiety?
I think in terms of the charging speed, it actually becomes faster and faster. I think once battery technology improves, I think we have a lot of types of batteries now available in the market. Some are talking about solid state battery, which at the end of the thing, they want to ensure that it's not as flammable as the before, or the safety thing. The safety thing is addressed, and also the faster charging rate. But to be frank, as an electric vehicle driver myself, normally if you were to charge it, it's like our handphone. You bring back your phone back to your house, then you use it, charge it overnight or charge it a few hours before you actually use it the next day. So same goes to our electric vehicle. You don't need to travel to petrol station. We bring it back home, you charge it at home. 90% of the time when electric vehicle users charges their car at home instead of in petrol stations and in other places, unless you are traveling outstation or you are traveling very far, or you forget to charge overnight certain days, then you only actually need to find the charging infrastructure.
Ah, okay. All right. All right. Okay. Thank you. And the last one from me is: do you think vehicle to grid will play a major role in future EV system?
I think vehicle to grid is going to be a future technology that has to be adapted. I think in future, the biggest utility company might not be the local utility company. It might be a company like Tesla, which is going to be a biggest utility company. We are talking about virtual power plant, which is currently one of the things that is very interesting. What is this virtual power plant all about? It's as you know that once you plug in your car to charge with the vehicle, for companies like Tesla, they can actually command, or they can actually send commands to actually have the cars to actually revert the batteries which are charged to be discharged to the grid to support the grid. So they can actually charge it at the time when the price is low or discharge it at the price when it's high. So it's actually part of the overall smart grid integration and also system which are coming to play. So I think V2G plays an important role in having this aspect.
Okay, all right. I think thanks a lot, Ali. I think that was
Yeah.
very beneficial. I think now we have some questions from our audience and participants, and I have some personal questions from some of the participants as well. So
Okay.
maybe Dr. Lily, you can share the question. Okay, the first one from Inche Amir Azrin. Is there any possibility of DC EV charging station in east coast of Peninsular Malaysia, example Kelantan, Terengganu, especially for those who are traveling long distance?
Okay. I think this has been one of our things that we are trying to address as well. I think the one that has been, I think we have actually doing testing commissioning now is 180 kilowatt at Gambang Petronas. That should be up really soon. So that one will help to alleviate those that wants to travel to Kelantan and Terengganu. Not forgetting that we will also be putting a few more chargers in Kelantan and Terengganu fast charger at some of the malls there. So we want to make sure that if you want to travel back back to your kampung in Kelantan and Terengganu, you are not limited by the lack of infrastructure there.
All right. Okay. Thank you. Right. Next question, please. Okay. This is from Dr. Helmi Hakimi from Unikial BMI. Hi. What about the challenges in safety and reliability?
I think in terms of safety, I think in terms of vehicle safety, actually it's quite safe in terms of what I think they have their protocols and also the battery management system to actually regulate and to ensure the safety of it. On the reliability, if you are talking about the charger, it very much depends on the maintenance and also the product itself. So for us, I think we have tested many types of products and also many types of thing. At the most, we will need to ensure is the product has local support and they have good reliability to ensure that you don't travel down to fix it every now and then. That is something that takes a very high priority in our choice of selection in terms of the products.
Okay. Thank you. Next question, please. This is from Encik Muhammad Hanif. Is there any courses training provided for those interested to become EV charging competent person?
I think currently there are a few companies, I mean, in terms of companies which are trying to set up, I think for us, we are mainly doing it in-house because when we were starting to do this, there are not many courses or many technical trainings to ensure that we are competing person. So we basically need to fly a TUV guy international because TUV is an internationally recognized thing. We flew the guy in from China to actually certify us because the OEMs that we work with would not want to work with us if we do not have this kind of certification. So that is also part of our things that we want to make sure. So the other thing that is we are also trying to work with some of the training universities and also the authorities in coming up with some modules to actually help in terms of train the electric vehicle charging competent person.
Oh, okay. All right. Thank you. Next question, please. This is from Mr. Sugindran. It will be great if more charging stations are installed in city center areas in every state to increase EV adaptation. How can this be done with the current change in environmental conditions, flood?
I think what you mentioned, it's in like I mentioned earlier, in city centers definitely we will also put chargers along the popular route. But mainly, if you have an electric vehicle, your first thing that you need is to have a charger at home. That is 90% of the time when you're going to charge your car. Then in terms of the current environmental condition, I think this is not only what charging stations are facing. I think in terms of other electrical equipments or utility are also facing the same thing, like substation and etc. What you need maybe is to plan and to have maybe cement plane to elevate the level of the charging station higher, so that at least you have some deterrence and also some measures to reduce the flood. I mean, if there's a flood at the area lah.
All right, thank you. Do we have another question? Okay, this is from Che Amirul Azman. Some of the petrol stations use solar panel to support the charger. What sort requirement needed in determining the battery size MPP for supporting the charger system?
Okay, I think for us, if you want to have a standalone system, you will need to ensure that you have a battery system in place. A standalone system means the charger doesn't take power from the grid. So I think that is what we call a standalone system. So you will need to ensure that if you are installing a 50 kilowatt charger, your output of the inverter has to be at least 50 kilowatt. If you are installing a 50 kilowatt hour of battery, you must ensure that the discharge speed is 1C. So for us, if you want to have this kind of discharge rate, the battery might be more expensive. So for us, we might even size it slightly bigger, like 100 kilowatt hour, so that we can have a 0.5C discharge instead of having a 1C discharge. So I can actually lengthen the lifespan of the battery. So these are some of the things that plays a part. But for us, I think now we still use solar with the support from the grid, so that we do not have we do not need to deploy the battery, expensive battery as part of the solution. But if you want to do a standalone system with the battery support, I think that is some of the things that you need to take note in terms of the sizing of it.
All right, thank you. Next question, please. This is by Encik Ahmad Sukri. Can the current EVSE EV charger charge all types or all brands of EV? He means that one charger can suit all kinds of EV. Is there any real challenge regarding this issue?
I think one of the things that we encourage, if it's a public charger, I think we encourage and say that why not you put a socket type of charger, so that the owner brings their own cable to the thing. So it's like a power bank. If you want to use your power bank to charge your phone, you have a USB to an Apple adapter. If you have a Samsung phone, you have a USB to a Samsung adapter. So you bring your own cable to charge it in. That I think makes the charger universal, and I do not have much maintenance in terms of the cable tangling and the charger itself. So that is some of the solutions that I think makes sense to have a universal charger in the public.
Okay, all right, interesting. Next question by Encik Amirul. What are the capacity needed for solar panel battery system?
I think, like I mentioned earlier, you need to size according to the battery. Then, of course, if you were to size your solar panel, then you will see either peak sun hour is about 3 to 4 hours per day. Then you will need to multiply how much you need to replenish your batteries. I think that is part and parcel of the whole overall design system.
All right, thank you. Next question. This is by Mr. Tiang. By considering the 10,000 charging stations, will the TNB possess sufficient power supply, especially the maximum demand, when all stations are charging at the same time?
Okay, you see, this is one of the good thing about electric vehicle. You know that when you go back at home to charge, normally it's always the non-peak. So it's when the usage of electricity in the country is actually very low, because most of the people, when they come back from work, they only charge their car. So the peak time, even though you have 10,000 charging stations, you are actually charging it during the non-peak period. So actually it helps in terms of the generation side for TNB, because the peak period is always in the afternoon. I don't think in the afternoon you will want to charge it. Normally, the majority of the users is going to charge it at night after work, once they are back to office, back from home.
All right. Okay. Thank you. Next question, please. By Mr. Tiang Tao as well. Will the incident of power swing happen? What is the percentage of power reservation should we have if there are about 10,000 charging stations?
I'm not sure about that. I think there's a study done previously. They say that if there's 1 million of electric vehicle running on the road now, the current generation and current electricity supply is still able to cater for that.
Okay, all right.
Yeah.
Okay, next question, please. This is by Mr. Gautam Raj. You have developed solar-based EV charger. How are you balancing the grid, and is it really helping for DC fast charger?
Develop, how are you balancing the grid? And it's a, I think the solar based charger, the solar is only to support the EV charger. It's not to entirely power up the charger. If you need to power up, like I say mentioned earlier, you need to power up entirely the charger, the standalone type of that. You need batteries to support it. So for us, we want to make sure that the net usage of the charging electricity comes from the solar, so that we can we green off the energy generation on the electric vehicle side of it.
Okay, right. Next question, please. Okay, by Mr. Gautam Raj as well. How about balance between charger and grid when there is no EV?
I think the solar that we actually put it, if there is no EV, I think it's being consumed by the petromat at the petrol station. So I think that is how it is being done.
All right. Okay,
Uh,
interesting. Okay. Is there any other questions? Okay, by Mr. Tiang Tao. Since the DC charger is more promising, will the infrastructure of DC transmission lines more optimal in terms of cost and its operation compared to that of the DC charger itself?
Not promising. Yeah. So we did consider that previously. I think when we were toying the idea of since a DC charger you have it's actually a DC thing, but the problem is all the manufacturer which makes the DC charger they requires an AC input. We did buy a DC charger which requires DC input because we did a project, but the charger is not very reliable, and we find that there's actually a lot of issues. So having convert in terms of as an electrical engineer or as an engineer, we think that why you want to do conversion from AC to DC, then DC to AC again? It makes no sense. So, but on the product side of it, there's not much selection for you to have a DC input, DC charger. So that
Okay.
is one of the things that I think will not happen so soon, unless any companies can actually come up with a very reliable DC input DC charger.
Okay. Okay. Interesting. Any other questions? From Encik Farid Saleh. For Malaysia market, only have 5 standard regulated checked by Green Tech. Is there any other standards that we need to comply?
I think there are also standards from IEC. I think there are MS IEC, and also I think now ST is also coming up with standards to actually govern the installation. So I think that is something I think we will need to take note in future once the thing is up.
Okay. All right.
Nah.
Thanks. Right. Next question, please. By Mr. Gautanraj, do you have any plan for V2G or V2H concept in the future?
I think we are the only one which has a V2G charger here in the country now. I think that is what we are currently trying to do with V2G. We want to make sure that in future when this thing takes off, we will understand better how does the concept work to V2G. I think I'm always a believer of V2G will be the future in 5 to 10 years time. So before it actually kicks off, I think it is good for us to actually study the mechanism and also the system on V2G.
Oh, okay. All right. Thanks. I think we have a thing. Yeah. Okay. Will it have a high impact on the grid for sustainable, also for sustainable system?
Will it have high impact on grid also for sustainable system? You mean the charging?
I believe the V2G. I believe it's the V2G. Will it have a high impact on the grid?
I think it helps in terms of the grid management. With V2G, I think you can have more, because now V2G, if you are talking about V2G, you don't need to use those peak power plant to actually shoot up and support the grid. So with V2G, I think people are actually paying you to actually support the grid. I think eventually people are actually paying you to actually charge or hook up the car to the charger. So your car might be free in future as well because they are paying you to actually hook up that kind of power.
Okay. All right. So, is there any other questions? By Mr. Abdul Qadir Al Sharif, would like to ask about the integration of RES. How the energy can be managed?
How the energy can be managed. So I think you will need to make sure that you have a microcontroller. Then you set according to the threshold that you want to charge and discharge the battery. Then from then on, I think it depends on your threshold lah. Then before and when you want the charging to charge when it's off peak or when it's peak. So these are some of the things that you need to put inside the algorithm for you to manage the energy lah. As if I understand the question correctly, yeah.
Okay, all right, thank you. And I have, I think, three personal questions from Inche Ahmad Rais.
Uh,
He currently asked, how do you view the current deployment of V2G in Malaysia in general?
I think there are a lot of R&Ds and studies and simulation on that. In terms of practicality, I mean, in terms of application in real life, I don't see that many now. But I always feel that V2G is going to be a very important aspect in the grid sustainability and the smart grid of the future lah.
Okay. The other question will be, how do you view the deployment of wireless charging of EVs in Malaysia?
Wireless lah. Okay, I think there are a few universities are currently doing wireless charging in terms of induction charging. I'm not an expert in that, but to actually have that kind of traction, the OEMs or the vehicle manufacturers will need to adopt the receiver of this thing. Then only the induction charging will works. If the manufacturer doesn't push for this wireless charging, the thing wouldn't move because if you were to retrofit the car to a wireless charging, it will cancel off all the warranties that is attached to the car. So that is why I think working with a car manufacturer to push this will be the first thing. But so far, I've not seen a major company which has a breakthrough in terms of wireless charging with OEM company lah.
Okay. And the final question by Incha Ahmad
Okay.
Rais is, currently, most of the charging station management system developed in the market, what kind of architecture are they using? And are they using any cloud computing architecture?
I think most of the we call a charging system management, charging station management system, CSMS. I think they definitely need cloud system lah. I think some uses Google Cloud, some uses Amazon. So it depends on whichever supplier things we are using. Some in terms of language wise, some uses Python, some uses Java, some uses Ruby on Rails. So different CSMS has different topology and also the system language lah.
Okay, thank you. And I heard there's one final question that came in.
Last question. Yeah.
Yeah, last question. By Mr. Tiang Tao. Is there any subsidy of installing EV charger, either public or for personal use, or tax reduction?
Okay, I think in budget 2022, they have a reduction tax relief of 2,500 for personal charger if you install at home. Yeah, either in that is a personal tax lah, relief that I think the government provide. That one is not only including charger installation, charger sales, it's also including the charging subscription. Then we also have the GITA, Green Investment Tax Allowance, that you can actually green investment tax allowance that you can actually benefit as a company for charges which are owned for own use. So that is some of the things that you can take note lah. Okay, so I think that should be all.
Yeah, I think so.
Okay.
I would like to pass the session back to our moderator, Dr. Lily.
Thank you, Dr. Kanendra. Thank you, IR Lee. Okay, so I'm sure everyone had obtained valuable knowledge from the speaker. With that, we have come to the end of the program. I hope all of you could support all of our upcoming event. So don't forget to follow our IEEE PES Malaysia and IEEE UITM Student Branch Facebook, Instagram, and YouTube channel. Stay safe, everyone, and Assalamualaikum warahmatullahi wabarakatuh. Goodbye.
Okay, thank you very much, everyone. Bye-bye.